Hello, thank you all for viewing my poster. This is based on my master's thesis research on the stratigraphic architecture and characterization of the Windermere Supergroup. The Windermere Supergroup, or the WSG, is a Neoproterozoic succession of deep marine to continental strata that record deposition in the passive margin basin associated with the breakup of supercontinent Rodinia. At Castle Creek Study Area in the northern Cariboo Mountains of British Columbia, Canada, the Upper Castle Group and the Isaac Formation are exceptionally well exposed due to the vertical dip of the rocks and the recently deglaciated terrain, which has allowed them to be studied down to the millimeter scale. This project focuses on strata of the Isaac Formation, a mudstone-rich succession interpreted to be levied slope channels. In the deep marine, sediment transport is dominated by sediment gravity flows. These are flows in which gravity acts on the grains rather than the fluid, and they can take many different forms depending on the dominant particle support mechanism and sediment concentration. Focusing on turbidity currents, they deposit a characteristic suite of sedimentary structures known as the Bouma turbidites, where TAs are massive or normally graded sandstone, TB and TC are planar laminated and ripple cross-stratified sandstones respectively, and TD and TE are diffusely laminated siltstone and massive mudstone respectively. At Castle Creek, three main architectural elements have been identified. Overbank elements, which includes proximal levee, distal levee, and abandonment elements. These are associated with overspilling processes of channelized flows and channel deactivation. Channel elements, aggradational and laterally accreting, where laterally accreting channel elements are observed to sharply overlie aggradational elements, and this transition is interpreted to be the result of a modification of the granulometric makeup of the sediment supply in response to relative sea level rise. And mass transport elements, or MTDs, consisting of debrites and slides, where the development of different types of MTDs is indicative of periods of major instability on either the slope or the shelf. X-ray fluorescence, or XRF analysis, was also performed to analyze the bulk composition of mudstones along three vertical transects in the study area, and I have used a set of major and minor elements as proxies to interpret the data in sequence stratigraphic terms, as shown in this figure here. Zirconium, titanium, and silicon commonly occur in the sand and silt-sized fraction of detrital sediment as heavy minerals such as zircon, ilmenite or rutile, and quartz. Clay proxies are aluminum and potassium associated with kaolinite and illite, and the carbonate proxy is strontium associated with aragonite, as well as calcium, magnesium, and manganese associated with calcite, dolomite, and organic matter. Recurring stacking patterns of architectural elements in combination with these chemostratigraphic data has established a link between the two, interpreted to be controlled by changes in relative sea level. I've used this relationship to create an idealized depositional model of levied slope channel complexes in response to long and short-term relative sea level fluctuations. High stand and falling relative sea level, or the high stand and falling stage systems tracts in sequence stratigraphic terms, are dominated by calciturbidites, or more commonly, mass transport deposits. Calciturbidites indicate flooding of the shelf and activation of the carbonate factory, and are associated with elevated carbonate proxy abundance, whereas MTDs represent a period of major instability associated with relative sea level fall. Relative sea level low stand, or the low stand systems tract, is characterized by the presence of aggradational channel complexes, where sediment is delivered directly from the hinterland to the basin via the shelf edge delta. Carbonate proxy abundance here is generally low, and siliciclastic proxies typically exhibit an initial increase followed by decrease as relative sea level begins to rise beyond the sequence boundary. Laterally accreting channel elements sharply overlie aggradational counterparts and characterize relative sea level rise, or the transgressive systems tract. The gradual expansion of the shelf during long-term transgression results in coarse palimpsest and relict sediment being moved to the shelf edge during short-term falls of relative sea level. The better sorted character of this bimodal coarse-grained sediment supply causes flows to adopt a sharply bounded two-part density structure that promotes lateral migration and deposition on the inner bend of the channel. Carbonate proxies initially increase and then gradually decrease upwards, interpreted to reflect an initial period of carbonate production on the shelf, followed by drowning of the carbonate platform. Coarse-grained proxies increase, whereas clay proxies generally decrease, reflecting the dominantly coarse-grained nature of laterally accreting channel elements. Thank you for listening, and I hope you enjoy the rest of the conference.